So there is a rollback. We have had to use it once. So for the most part, it really depends on the nature of the problem. So there are several options that are available. Like one is to selectively disable the feature. Number two is to make a patch release. Number three is rollback. And there's some things that we do that make rollbacks a little bit easier, which I'll talk about a little bit later. Yeah?
So the release testing, I assume is a combination of the manual and automation testing. So is that your entire team? You just mentioned you have only one tester versus 9 developers.
That's right.
Is the entire team doing the release testing, or is just one tester doing the release testing?
So we generally have the majority of the team focus on testing on that day, but the tester is testing the software throughout the week. So it's just that is the day that we really focus on testing the new features and ensure that everything is solid with the system. And we do a regression test. Yeah.
What data are you using for testing? Are you using some test data, or are you testing it on production data?
That's a good question, and I'll talk more about that later too. But we use production data. So one of the practices that we use is we restore the latest snapshot of the production system, or at least a cleansed version of it, to our test environment once a week, and it can be triggered on demand. To me, and okay, well, I'll just talk about it now. I can skip the slide later. But to me, test data is a liability. So the more test data that you accumulate, the more perceived value in that data, the more reluctant people are to getting rid of that and to refresh it with a copy of what is actually occurring within production. And it introduces several dangers. Number one, it means that you're testing using test data rather than testing using what users are really seeing in production. So it means that you may find problems that could be an artifact of the data that is being used for testing. And it means that testers are not necessarily looking at the system from the perspective of a user. So having the ability to have the most recent production data, going through a user account, see what that user is seeing is really, really valuable. I've found. I mean, of course, it's not possible in every environment. Generally, there are ways around it by ensuring that the appropriate levels of compliance are met and that the data is properly cleansed. And I mean, our data, we've got more data in production at this point in time than we can support with, at least within local sandboxes. So we do truncate when we deploy it to development. Every developer also has a copy of the database. We deploy it to a local developer database. They have a truncated copy that's only got recent data for a selection of clients. But I think working with real production data is absolutely key.
Owen,
Yeah.
in the last year and a half, do you have statistics about rollbacks versus removing the broken feature? How many times did it happen?
So we've done one rollback. We've probably had to make 10 to 15 patch releases. Patch releases will generally come out the next day, depending on the nature of the problem. You know, some problems can be dormant within software for a while, and then they're discovered. There are a number of things which I'll talk about in just a sec, which help us identify problems within our system very quickly, so that often, instead of relying on, let's say, our customers saying, hey, I've got a problem, we know about those problems as and when they happen, and so we're in a position to respond as quickly as possible. So one key thing about working at this type of a pace is that it needs to be sustainable. So the analogy for me is like it's starting up any sport or any sport that you haven't done for a while. Like when we started doing this initially, it was definitely painful, and there were some late nights. But over time, especially as things became more and more automated, it became much easier. And at this point, it's really kind of integrated into the regular heartbeat of the team. It's just a part of the process, and it's how things work. It doesn't matter who's there on the team. It's just that is the process that we follow. We deploy software every week, and people know what's going to happen. So it It just kind of works around itself. And so I have found it really advantageous to just pick and fix a regular release window. One thing, I don't know how many people have been following, like there's a lot of discussion about Kanban within the Agile community. It's a hot topic right now. The focus on with Kanban is release stuff when it's ready, and that can happen at any point in time. I found that having a regular heartbeat around releases to be quite valuable for the team, and it's not just for the software team; it's also for the broader organization. People know when the window is for suggesting changes, and they know when they can expect new features coming into the software. So another thing, of course, also doing this so frequently is it needs to work for the long term. So not just in terms of people's overall quality of life, but the quality of the code also needs to be maintainable. So it's not just a matter of like rush, get something deployed, rush, get something deployed, because sooner or later that's just going to fall down. So there needs to be some sort of balance where people have the opportunity to go in and ensure that code is of the appropriate quality to support this type of process. And I was just mentioning it becomes part of the culture and part of the overall heartbeat of the company. So based on what I've described so far, like, is this Agile? Is it Scrum? Doesn't really sound like Scrum to me. I'm not a big advocate of Scrum, but that's my bias. Is it XP? Not exactly either. It's definitely more like XP. Is it Kanban? Not really, not exactly. So what are some of the things that are missing from those other processes? I'll focus on XP because that's what our process is most like. User stories, don't really do them. So generally for features that you can do complete within a week, where you have direct access to a product manager or whoever it is that requests that feature, you can have a conversation about it. Some of the stuff that goes around, I mean, user stories are designed to be extremely lightweight, but even some of the process around it, like let's say even the standard user story definition, as a person, I want to be able to perform some operation so that I can receive some business value. It doesn't really feel necessary. We use Jira as the basis of tracking what it is that we're working on. Estimation, don't really do it. Certainly not on a week by week time frame. Really, we look at does it fit or doesn't it? Is this doable within a week? If it's not, let's figure out how we can break it down so that it is. And the nice thing is it's a really short time horizon. I mean, for me, I am not great at looking out a long ways in the future. But I can visualize a week, even with a weekend in the middle of it. Yeah?
I just have a question. If you have a feature that it is kind of can be broken down, but you're not going to actually deliver anything until it's all done, are you still going to push that code to production?
Yeah. So, and that's part of building the software in a way that supports this type of release. So and so our context, as we defined it, is that this software is going to production every Wednesday night, unless there's a problem, a serious problem, right? So that going into it. So that means you need to ensure that when you're building the feature, you've got some mechanism for being able to enable or disable it. And that actually provides additional value, because then you've got the ability to incrementally roll it out for organizations potentially. You've got the ability to selectively kill it if it turns out that there is some very heinous problem with it that was unexpected. So it does provide a lot of flexibility. You have that discipline from the start.
So you never create feature branches or anything like that?
No. So I mean, at some point, so we occasionally, in general, we try and ensure that everything can be complete within a week and released to users and deliver value. If it can't, it's definitely fine that it will span a couple of weeks, and we'll recognize that and acknowledge it. But we want to ensure that there's always something that is visible, always something that is demoable. It may not be accessible to all users. It may just be accessible to super users, internal users. But we want the ability to be able to get feedback from even it running in the production environment, potentially using production data, as it's being built up.
Oh, and it looks like in this case your system is very well architected and very well maintained. Can you say that this is the case?
I'm flattered that you might think so.
Well, how
I
otherwise?
think the quality is reasonable. The key thing is, to me, is about having a context that requires this. When you're operating on a longer release cycle, then there isn't necessarily the same sort of need there to support it. The value may still be there, but there's not necessarily the need. Pairing we don't do religiously. We definitely do pairing. We have a culture that is totally accepting and encouraging of open collaboration. Everybody sits together around a big table or two tables, so there's lots of conversation that's happening all the time. Developers will sit down next to one another. But we just kind of, we pair as needed, so if somebody's working on something critical, we'll pull somebody in to help them. But it's not legislated by our process. And that, I mean, I think that's part of it is emerged because, like, when I joined, I was a third developer, and you're a team of like 3 people, and you're a startup, and you're trying to go quickly. It felt like overkill. But it's something that we do. It's just not rigidly enforced. But the other thing that we do to compensate for that is we do have code reviews. This is nothing official. This is more just cultural. So developers on the team, as they're merging changes into their local sandbox, will review those changes. And if let's say Anton's on my team and he spots a problem with my code, or something that he doesn't understand, or something that he thinks can be done better, then he'll come and talk to me. And so we try and ensure that everybody on the team is just regularly diffing the changes. And the key thing, I mean, this is not just about, looking for Anton to help improve the quality of my code. It's also for Anton to keep on top of how the system is changing and what new features are being introduced, because we are going pretty quickly. The open workspace thing I just talked about. TDD, this one I definitely have some chagrin about, but we don't really do it. This is something we definitely should do more of, and we need to get better at. But like one of the things, how many people are working at a startup company? Okay. I mean, if you're working on a product that's got an established market, it's very clear where the value is. It's very clear that there's risk in keeping the software fully functional. If you're in a software startup and you're going after a new market, the risk is not so much in the software. The risk is more like you're not going to hit the market. Like what you're building, I mean, really, you don't know what users want because users don't know what they want. There's no established market. And often you're building something as you go. And sometimes, you'll have an idea for something, you put it out there, and it just won't meet the need, and you'll need to throw it away.
Can you refresh my memory?
Sorry about that. I am assuming a certain level of familiarity with some of these concepts. So TDD is test-driven development. So what that means is writing tests for code before that code is written. We definitely do automated unit testing. We have about 54% coverage. We have some coverage from Selenium, but the Selenium work has fallen by the wayside. And I think there's definitely more focus on the unit testing through JUnit, but this is something we need to get better at. This is another graph from Teamcity showing our test count going up over time, not going up fast enough. So what we try and focus on is ensuring that we're testing the areas of the software that are most amenable to unit testing, that are the hardest to support through manual testing. So things like our software tends to be very calculation intensive because we're processing all of this raw meter data, and we need to ensure that those numbers are calculated correctly. Trying to test that manually is extremely time consuming. Having automated tests, but this is like really the sweet spot for automated tests. So these are areas where we have a high degree of coverage and we have a low tolerance for any potential problem. Whereas UI-related issues, I mean, we do strive for this to be a Web 2.0 application. There's extensive use of JavaScript and Ajax, and it gets pretty tricky. But it's definitely an area for so don't get me wrong. By the way, I should clarify. For when I'm saying these things, don't really do them. I'm just describing this is the process that we follow. I'm not saying that these things are not necessarily bad or necessarily good. This is something I definitely think we should be doing more of. But part of the reason that I emphasize it is that when I talked before about releasing software this frequently, people often say, like, in order to do that, you must have 100% test coverage. Your test coverage must be absolutely amazing. And my experience now is like, well, actually, it's not necessary. And people often say that because they say, well, our test coverage is terrible, so we can never do this, right? And I'm saying, well, you know what? Actually, you can do this with systems that have lower levels of test coverage. It just means you have to be more careful.
I agree that it's a bad thing, but at the same time, you can throw away your tests after you're done your design. But I'm wondering if that's what you're doing when the line is sort of flattening, is that you're maybe doing some PDD, but then as soon as they fall out of favor with some refactoring, you just chuck them.
No, not at that level of discipline yet. Retrospectives, don't really do them explicitly, not like in the sense of like the formal Norm Kurth style retrospective. We do, as part of our planning meetings, review the previous release. This is more just done on an informal basis. One thing we do that I will talk about in a little bit more detail is we follow the process of 5 whys, especially around about any type of production issue. So 5 whys is like it's a very lightweight root cause analysis tool. Essentially what you do is you ask the question why 5 times. So here, unfortunately the contrast is really bad, but this is just a simple 5 why exercise where you capture on the whiteboard. So what you start with is some sort of definition of the problem. So what is it that happened? And then you proceed to ask the question why that happened 5 times. And typically what will happen is that you'll start from something that is very technical and move up to something that is generally process and people related. And the idea is that for each answer that you give, you want to be able to take an action that will help you mitigate that problem. So the whole goal of this is we want to ensure that and we can have any problem happen to us once, but we don't want to have that problem happen to us again. So it's really kind of fostering an attitude of continuous improvement within the team. And often, and this is actually was quite surprising to me after doing this a few times, was that by continuing to ask the why question, the answers were more unexpected and insightful. So often I found, like, if I found a problem, I rushed to try and fix the problem and not necessarily go after the root cause. And it doesn't mean you have to fix the root cause. It just means you have to move take an incremental step towards addressing that problem. So, yeah. Anton,
How
go
do
ahead.
you keep your tribal knowledge? So you have found answers for those 5 whys.
Yeah.
Do you put them on Wiki, or do you have some other knowledge base for those dev issues?
We do, yeah. So generally at the end of it, we'll capture a photo of the whiteboard, and then each of the actions will turn into an item in Jira, and then it will be scheduled accordingly. So some of the key things about this is it's designed to be extremely lightweight so that you can do it at any time. Because generally the value associated with conducting a review decreases depending on how far away you are from the actual event. Especially for something that's serious and something that is like very specific. You have a specific problem, you're looking for a set of solutions for it. So we strive to do our 5 whys exercises within 24 hours of a production incident. And as I was just saying, Anton, we'll have like one Jira per question. So one action that we plan to take for each of the answers to the 5 questions. Any questions about that? It's really valuable. I mean, for us, like I've been reading about it, I hadn't tried it before, and we just said, let's try this. A lot of the information that I found on the internet about this is fairly vague, so we kind of stumbled through and said, well, let's just see what happens. We'll put some stuff up on the whiteboard, and then we refined that a little bit as we person who fixed the problem.
It's like using first directive permanently.
Yeah, exactly.
Joel Spolsky has a good essay on the 5 whys technique, and it's a good starting point if you want to try it. We started doing it after reading that, and it's worked well for us.
Eric Ries is the one who.
Yeah, I was reading a bunch of stuff on Eric's blog.
What's your turnover since
Zero. Yeah, we haven't had anybody leave. Oh, sorry. Okay. Well, we haven't had anybody leave the development team because of any sort of problem like this. People left because they were going back to school. That was good. Do you have a question?
Yeah, have you found that over time you do less of these 5 whys? Now the process sort of improves?
I would like to say that we have been doing less because we've been improving. I think we've been doing less because we've become a little bit lazy. Complacent was the word I was looking for. So this is what part of the reason why I like doing this presentation, because it reminds me of some of the things that we should be doing more of. Okay, so let me move on, because there's more meat in some of the rest of the stuff. I'm going to talk about some of the practices that support our process. So daily support rotation I talked about, 5 whys I talked about, continuous monitoring. This is something that is providing us with a lot of value. Essentially the idea here is that we want to monitor all of our systems, not just the production systems, but systems and tests, so that we know about when problems happen as soon as they happen. And there are a number of things, number of tools that we have in place that support this. So one thing that we do is all log messages that are produced by our system of error or warning status are routed to a socket asynchronously. We have a daemon that's set up running on each app server, and it emails out to the support team what that error is. So as soon as there is a log failure within our system, we know about it. And that I found has been hugely valuable. I mean, a lot of systems that I've worked, just a sec, a lot of systems I've worked on in the past, I guess I'm going to talk about this next, but a lot of systems I've worked on in the past, any type of log analysis is always post hoc. It's like, something bad happened within the site. Okay, let's pull down the log files and go through and we'll try and reproduce what's happened. Whereas this is really proactive. Like, as soon as an error happens, we know about it. Now, there are definitely some challenges associated with it, which I'll talk about in a second. You had a question?
It might be related to the challenges you were about to mention.
Okay.
But my question is, how do you stop from melting your servers?
Good. Okay, well, that's the next one. So this is something that happened to us early because we didn't think things through as you might have. So generally when problems happen within production systems, they don't just happen once, they happen repeatedly. And they can happen so frequently that your mail server can be identified as being a source of spam on the internet. So we got blacklisted by Google, and pleased to say that yes, we are legitimate, and yes, we've addressed the problem. So part of the reason that we route to a daemon is that the daemon is responsible for throttling. It essentially maintains a map in memory of of messages by logger, and we have a timeout window. And so if it receives messages within that timeout window, then it will ignore them. But they'll generally be of the same type. They'll still be written out to the log files. We just won't receive a huge raft of emails about them. But it is something to manage. The point that I skipped is having this sort of process, it really encourages you to keep clean logs. So in the past, when I've gone in and done log analysis on production systems, like you start to look at what is there, and it is crazy. I mean, you find class cast exceptions, full of null pointer exceptions, all of these things that people, the development team is completely oblivious to. Things that should never happen in production systems, things that are clearly programmer errors that, for one reason or another, never bubbled their way up to the user interface, but that are happening all the time within systems nonetheless. So this provides a very high incentive to keep these things clean. But it does mean that we get a lot of email, so using a good mail client that supports threading is quite helpful. Another thing that's key is managing the signal-to-noise ratio. This is something that my colleague Chuck here set up when he started. Is setting, we have an automated script that generates a Pareto distribution of the ratio of messages per logger, so that we can determine like what's the main source of problems right now within our system, and then within a week we'll say, okay, we're going to pick off this problem. And the thing is about getting emails is it is sufficiently annoying that there is a real incentive to fix the problem that's shared by the development team. Okay, so other sorts of continuous monitoring that we do of our system. We use a third-party service called Pingdom. How many people have heard of Pingdom or AlertBox? If anybody here who's building a web application, take a look at this service. It's fantastic, I think. So what it does is it will ping your site on some sort of regular interval that's configurable down to a minute. So we have this pinging our site every minute, as soon as from a large number of servers all around the world. So as soon as your system is not accessible, it sends you an email and it tells you that your site is down, and then it will, once your site comes back up again, it tells you how long it's been down for, and then it generates a weekly or a monthly report that calculates your uptime in terms of nines. The service is free for like one IP or URL that you want to ping. So it's just a great way to go in there and get set up. Like I got it set up for my blog because I went to contact somebody and I noticed that their blog was down, and I sent them an email. I said, "Oh, you probably know your blog's down." I said, "Oh, I had no idea." And I thought, "Oh, okay, maybe if my blog went down, I'd have no idea. So maybe I should go set this up." But it's a great way to play around with the service, and it provides immense value. We have it not just pinging our production servers, but also our test environment. When things go down in test, again, you want to know about it, especially when you're operating on this type of a short cycle. Yeah.
I just want to get, earlier when you were talking about your product, it didn't sound like a website.
It is, yeah, it's a web application.
It is.
Yeah.
So you're going to talk about the zero downtime when you're loading code?
Yep.
In more detail? Okay.
That's going to be the next practice. So just a few more things about continuous monitoring. We use a system called Ganglia that provides system level and application level metrics. Cacti is another one that's up there that people seem to be using. Ganglia is used by companies like Yahoo and Flickr. It's used by Wikipedia. If you go to ganglia.wikimedia.info, you can see the status of all the servers in the Wikipedia clusters. And it's pretty interesting. Like you can see how they've layered their architecture. At any given point in time, there's quite a large number of servers that are down. So here's an example of what a Ganglia chart looks like. So this is just monitoring standard system metrics like CPU, memory, network I/O. But one of the nice things about it is that it's extensible, so you can hook it in to monitor different things within your application. So we receive, for our system, data from a wide variety of different data sources, and that's dumped onto queues. We need to ensure that we've got sufficient capacity within our system so the queues don't back up. So we do monitoring of things like queue size, connection pools are another big thing, HTTP connection pools, JDBC connection pools, memcache servers, things like that. All of these things, there are third-party plugins that you can get that will interface with Ganglia. But it's a very useful system. And again, following this mantra of what we do in production, we do in test. We have Ganglia set up within the test environment, because if we are making changes to a system that introduce a performance problem, or one of these metrics spike, we want to know about that before we get into production. And here it's monitoring the database. We've got it monitoring something like over 50 different metrics from MySQL due to some third-party plugin. We also do monitoring of the system, our system from within the system, both for our information and for many of the other users. So as I was saying before, because we interface with a number of different sources of data, they are potentially unreliable. So we've got internet connectivity gets shut down for a building, or there are systems that we're monitoring that are inside the building that get shut down. We want to know about them, so we've got monitoring for that within the software. Other types of monitoring that we do, we monitor, this is as of fairly recently, we do user tracking. So we know who's on the site, what they're using, how frequently they're being used by, they're using different features. So there's a wealth of information that you can get from the use of your site. So, and this is something that we're just starting to take advantage of. And this is doing things like this is something that I've helped set up for other companies in the past, like pulling in your web server logs and doing web server log analysis, but doing it continuously. So rather than doing it like once a month as some sort of a batch upload to the server, but having and then you go through you do whatever sort of analysis you want, having this information available all the time that is part of your software that at least anybody with super user access can go in and take a look at who's using the system is fantastic. It's great information for the sales staff. They can go in and they can see, oh yeah, I can see the last time that my accounts have been using the software, and I can see what parts of the software they've been using. Yeah.
From an architectural perspective, do you parse logs and store results in database, or do you parse logs on demand?
The way it's implemented in our system is we have a cron job that pulls in the web server logs and writes it to a database on a regular basis. So all that information is stored within a relational database. Because a relational database just makes it very easy to support analysis. Okay, so zero downtime deployment, that was something that was asked about. So every time we do deployment, our goal is for there to be no visible impact to users. So at the app server level, this is pretty easy, or pretty standard. You have some type of a load balancer, whether it be hardware or software load balancer, and you need to ensure you have at least 2 app servers or web servers. So you can pull one out of the load balance pool, upgrade it, put it back in, pull the other one out, upgrade it, put it back in. To support this, we're using Nginx. Nginx is a very lightweight reverse proxy web server implemented by some serious kick-ass Russian programmers. They've optimized the hell out of it. It's very lightweight, very high performance, quite extensible. So it also serves as a software load balancer. So we use it within our test environment because we're too cheap. Well, actually, we don't really have the need to have a hardware load balancer within test. But we've also found that configuring Nginx is easier than configuring a hardware load balancer, so we use it in production as well. So we have a hardware load balancer that roots Nginx, which roots to our app servers. There are other reasons for using it. It's like way faster than trying to serve up static. It serves up static content much faster than a Java app server. And it means that your Java app server's HTTP threads are dedicated to doing real work rather than serving up images and JavaScript files and things like that. So let's see. So the deployment is automated, at least for the test environment. It's a one-button deploy for Teamcity. So anybody can trigger a new deployment to our test environment at any point in time. For deployments to production, we don't have that through our build server. We want to ensure that it's a little bit more of a control process. There's a script that we run with the appropriate set of SSH connections open that will deploy new builds up to production. But it is still one script that is run. One of the challenges with this that we have dealt with and are still dealing with, when you're deploying this frequently, when you bring down an app server, it often it may not come down gracefully. So working on ways to acquiesce servers, especially busy servers, is a bit of a challenge, especially when you have something like continuous monitoring in place. So if you get emails because there are exceptions that are being thrown because you're bringing down a server, it's not necessarily something you want to know about. Well, what's better is you can bring down the server without generating those assumptions. Okay, so but what about the database? So this is fine for the app server level, pretty standard. But the database tends to be something that screws people up. Okay, I'll take a few questions. I'm just a little bit cognizant on time. So, did anybody have something that they want to talk about right now?
Yeah, I want to ask about your build process because you said it's just 3 minutes, I guess.
Yeah.
So how do you make it 3 minutes? I mean, generally we have builds like an hour. So the feedback time is too late. Like if I commit something, I'm gonna get response after 1 hour, right? So I'm gonna see that it's fault or something. So how do you do that? Or is your code base so small or something?
Well, the code base is probably smaller than what you're working on. But what is it about your build that takes an hour?
Yeah, we're running through several builds, but like for me, the important thing is like the tests and it's saying 20 minutes, for instance.
Yeah.
And it's testing all the important parts of the system, right?
Yeah.
So any feedback that I can get, the shortest amount of the time is like 20 minutes for me.
Okay.
So what's in your code base? Like how do you do that?
Well, so this is definitely part of a longer discussion. But you have to weigh out the value that the fit tests are providing you relative to the feedback that you get from the other things that are happening in your build. So you may still want to run those fit tests, but you may not want to run them as part of your primary development build. So have some sort of parallel build that could be kicked off on a period and run in parallel while this other one is running. But you may or may not want that to be, what is the primary guide of whether or not developers can check in changes. Anyway, it's a much longer discussion. Anybody have anything about zero downtime before I move on to talk about database?
I just had a quick question about the graceful shutdown. I mean,
Yeah.
why not just take the server on the load balancer before shutting it down?
Well, we do that. Yeah, definitely, right? But when you're bringing down a server, there are things that, like, not everything. So, okay, I'll give you a specific example. We have some longer running jobs that are happening within servers. So one of the key things is interrupting those jobs so that they shut down gracefully. And if you don't do that, then app servers will generally do things like abort active threads. And when they abort active threads, then that generates exceptions. But yeah, they're definitely pulled out of the load balance pool. We issue a shutdown, and then it's sort of. It's not. I mean, it's generally not such a big deal, but it's just more something to work towards. So for the database, we use a lightweight migration framework called Bearing. It is implemented. It uses Groovy as a scripting language. It's kind of a port of Rails migrations for those people who know about Ruby on Rails programming to the Java space. But the idea is that you build these individual change scripts which will move your database forward incrementally. So it'll apply the necessary set of DDL statements that will change your table structure in the appropriate way. And then we version them by release. So every week we'll create a new folder to contain the set of scripts for that week. Okay, so
Sorry.
yeah.
But if you're still bringing down one server at a time and then bringing it back up, that implies that you've got 3 then. You're running different versions of the software at the same time.
That's right, exactly.
And if the database is dependent on which version you're running.
Exactly. Yeah. So this is the problem that I'm going to describe here. So what's the problem with executing this migration? So I've got a snippet of SQL code. It's going to rename the login ID column on the user table to username, because we've decided username is a better name for this column. What's the problem with this?
Currently running app servers just farm.
That's right. So one of the key challenges with doing, like when it comes to the databases, you've got this chicken or the egg problem, right? You can upgrade your database and then all of your running versions of your application will break. Or you can upgrade the applications, but none of them are going to work until the database has been changed. So how do you get out of this problem? So the key idea here is that instead of treating it as one migration, you can treat this as 2 migrations. We have one migration which will add, let's say, the username column, and another migration, which could be run at some point in the future, that would remove the login ID column. So instead of doing that as a single operation, you can do that as two separate operations. So, so instead of having one set of migrations for every release, we have two sets of migrations. We have what we call the expansion scripts, and we have the contraction scripts. The expansion scripts are database changes which guarantee backwards compatibility with the existing version of the application. And contraction scripts go in and clean stuff up. So they will apply whatever sort of breaking changes need to be made. So you can do things like you can add a column to a database, and as long as you are doing sensible things like using an object relational mapping framework that builds SQL statements where it requests the columns that it knows about, then it's a safe operation. So you can have that new column in there. You can have a trigger in place that will synchronize those two columns, the values in those two columns, as the table changes and as new users are added, let's say. So it's something that's extremely simple, but it was something that we weren't too sure about when we started. There are definitely such things that you could conceive of that would create problems, but applying the 80-20 rule, like 80% of the time, this is something that you can get away with doing safely for making change to the database. Yeah, okay, so expansion preserves backwards compatibility, contraction cleans things up afterwards. Yeah?
What about large data sets?
So large data sets, so that's...
Like a giant index.
Yeah.
You create an index and it would lock up the database.
Well, not necessarily. It depends on what the sorts of changes are that you're making. So, but it's not necessarily going to lock up the database. Part of it is knowing what sets of operations are safe and which ones aren't. So here are some typically safe expansion operations. Not everything is guaranteed, but this is something that we review prior to making a release. So doing things like adding tables, adding columns, inserting data. Now, let's say, for example, the index that you're talking about, you're adding a uniqueness constraint on a column, or you're making a column that was nullable, non-nullable. These kind of things, they might seem safe on the surface, but they generally they belong within contraction scripts because they have the potential for breaking backwards compatibility. You can't guarantee that the previous version of the application didn't respect that uniqueness constraint, or that it could insert null data. And then so there's some typically unsafe operations, so renaming, removing columns or tables. These sort of things would go within the contraction scripts, or adding constraints, as I just mentioned.
But what if you're creating an index with 20 million rows?
Yeah.
You're screwed.
Well, okay. So there are certain things that may require you to incur downtime no matter what. But within our system, we've got a few extremely large tables. And sometimes, rather than making changes to the structure of those tables, we will add migration that will create a new table that will have a similar structure. We'll migrate the data into the new table. We'll add a trigger that will keep those tables in sync. And then, so the new table reflects the structure that we want to have in place now. And then once we've completed the database rollout, then we can drop the trigger, drop the table, leave old table. So that's one way that you can get around locking tables. Another thing, and this is something that we're starting to move towards, is sharding. And so I think that sharding also will provide some advantages in this way, where you can potentially, you can incrementally upgrade shards, and it should run a lot faster. Okay, so expansion scripts. So this just reflects kind of a folder structure that describes the sort of model that I'm talking about. This is one of those things that I just encourage you to try out and see how it goes. Because when we first started to do it, I wasn't too sure how it would work, but it's actually worked extremely well in practice. Yeah.
So you mentioned previously the rollback. So you run the expansion scripts, you migrate all the servers. At what point do you decide to run the contraction scripts? Because that's obviously the end of the rollback.
Yeah, so that's a great question. And that is the second point that I have on the slide. And which comes back to the question that Alex asked, which is like one of the really nice things about doing this is that it greatly simplifies your rollback process. So if you do discover that there are problems associated with the new version of the app server that you rolled out, you can roll back without needing to roll back your changes to your database. Because rolling back changes to the database is a hard problem. It's a very hard problem. So that's why we'll generally defer running the contraction scripts for a few days until after the release we consider it to be fully baked. So once we're sure that everything's fine, then we'll go in and we'll clean it up. And that also gives us the ability to, we'll run those contraction scripts against the test environment, and we will verify that everything works fine having run those scripts within test too. Another thing that's really nice about this, especially for what you guys are talking about, where you're performing operations on large tables, is that with this type of approach, it allows you to decouple the database migrations from your release process. So just like you can run the contraction scripts at some point subsequent to performing the release, you can run the migration scripts, expansion scripts, at some point prior to doing the release. That could be a few days prior to doing the release. So that means that you can minimize the amount of risk that you want to take on. So if we've got a significant risky migration, you can also then target your window for when you want to do that type of migration. And if you do need to take things offline, you can take things offline, upgrade them. The new version of the code is not running yet in production that would necessarily take advantage of it, but when you do release it, it is. So it provides you with more options, which is one of the key practices that I'll talk about next.
Have you ever thought about not using a relational database?
Yes. A lot, especially because what we're dealing with is large amounts of time series numerical data. It's not really what relational databases are designed for. We've been looking at a number of alternatives, but we're not yet of the size that we're truly pushing up against the boundaries of what we can do within a relational database, but I think we're going to hit that pretty soon. So maybe in a few months I'll come back and I'll tell you what our experiences are with Hypertable or...
It's only the alternatives with having problems with rollback.
I don't know, not necessarily. I mean, one of the things that's nice and that's part of what keeps us on the relational model is that it is a model that's well understood. And of course, for the rest of your database, for the most part, so you'll have these few large tables, but most of your database is of a size that is manageable, and you can do these things pretty easily, especially if you're doing it every week.
Owen, do you see any problem when deploying so often on the client side, where a wrong version of JavaScript is cached by client and there's some inconsistency of UI?
Okay, so that's a very specific question that I have a very specific answer for, which is that how many people have heard of the YSlow plugin for Firefox? Yeah. So YSlow it's a plugin that you can use that assesses the quality of your website in accordance with a variety of different metrics. And one of the things that it encourages you to do is to set far future expiries for all static resources that are served in your site. So what that means in regular English is that any images, style sheets, etc. are going to be cached on the client side for an indefinite period of time. So that means that the first time you go to a website, it will download those resources. Let's say you've got a standard set of style sheets that you want to use throughout your site, and it will cache it indefinitely for as long as the user comes back to your site, which is great, right? Because that reduces the number of HTTP requests, it simplifies, it accelerates the rendering on the client, so it produces a lot of benefit. But what do you do if you're releasing software every week? How can you take advantage of having far future expiry? So what we do for all static resources, we version them. So for every release, we bump up the version number associated with our style sheets and scripts specifically. We also do a few other things, like we minify and amalgamate all of our script and style sheets so that they're loaded up in one file. So that also reduces the number of HTTP requests that are issued to the server. There's a great book called, what's it called? building faster websites. It's by the author of the Wiseflow plugin, and he goes through and makes all of these suggestions about how you can improve the performance of your site. Especially as something like 60% of all visible wait time is derived from things at the web tier. Like it's not based on the sort of processing that happens in the back end that people typically focus on. So essentially there's a ton of stuff that you can do to make your website faster by focusing on these things. And for us, this type of versioning, it's all automatic. Actually, every time we do a new build, we reversion the scripts install sheets. Now it does mean that people, if somebody's using our site once a week, that means every time they come in right now, they're going to have to re-download the scripts install sheets. But for, at least for the duration of their visit within the site or within that week, they never have to download it again. So essentially the caching problem is under control. So that's very, I think you're probably asking about something more general than that, but that's how we deal with that specific problem. Okay, so yes, so some additional complexity of writing migration, because you have to think about what are the implications of this migration. Is it going to break backwards compatibility? Before we do a release, we always review the migrations that we're going to run, just to make sure that there's nothing that might have slipped through. Okay, so options are something that I've been talking about a fair bit within this presentation, but not labeling explicitly. But I think it's kind of a key concept. So the traditional release is like the Big Bang, right? You've got your window of time. The world is upgraded, right? Like the new version of the software is pushed out to every server, every user gets the latest version of the software. You know, it's like going from Windows XP to Windows Vista, right? It's like you got it, and that's your upgrade path. So it tends to be a really big change. It tends to be high risk. Because everybody is affected by the change. It's hard to scale it. So if you're scaling out to potentially hundreds of servers, trying to do this big bang, trying to incur downtime if you have an extremely high traffic site, it's just not really feasible. It also tends to build this mentality of like, we're not going to release stuff until everything is ready, which just prolongs the overall release process. To me, there are many different ways to release software. So instead of just having this focus on, everything gets, there's the release, right? Everything gets upgraded. Instead, there are options. And I tend to, this is something that at the last Agile Vancouver meeting, Steve was talking about, it's being discussed quite a bit within Agile circles, is this notion of real options and options thinking. So an option within financial circles is just a promise or it is having the ability to buy something, saying that I want to be able to buy something at a future point is worth something to me. So having that ability to be able to defer a decision until the last responsible moment has value, has monetary value, right? So maintaining my options, keeping my options open. And it's the same thing within a release. And if we're releasing software this frequently, we want to ensure that by Wednesday at 5 p.m., we don't have just one option, which is we've got to release the software. Instead, we've got lots of options at our disposal. We can say how we want to release it, who we want to release it to, whether we want to release it or not. So here are some of the options. So we can release to a user subset, private beta. We could conduct a split test. So we could expose some subset of users to some set of functionality, some set of users to some other set of functionality. We could roll things out incrementally, so we could roll things out only to a subset of servers. We have the ability to selectively enable or disable features. Selectively downgrade features, disabling features. There's also, of course, the option of deferring a commit, or committing on a branch. So if come Wednesday or Tuesday, you're working on something that you realize is going to have more serious implications for the software, you don't feel comfortable about putting it into this release, you can always commit that change on a branch that can then merge in after the release. And then, of course, there's always the option of deferring the release by a day or canceling the release altogether, which doesn't really happen that often. But the key thing is there are lots of options at our disposal about whether we release or not and how we release. And those options have value. So for some of the stuff about like selectively rolling out features by organization, like this is something that is worth money to your company, to me, right? And it's something that, like, especially when couched within financial terms, are things that the business, I don't know if you're people here from the business side of the organization, but it's something that they'll understand, right? Having that ability to, as opposed to committing, at the start of a release to exactly, what set of features are going to be in it and who's going to be available to, having that ability to decide at future points is extremely valuable. Okay, so there's several implications. One, we've talked about quite a bit of this already, but features are typically running in production before they're fully available to everybody. That means you can get lots of data about how those features perform, what people think about those data, those new features before they are exposed to everyone. And for us, release is really more of a marketing term. So what typically happens is, like, once every 3 months, we'll increment a major version of it. And we'll do a press release. And we will say, and we'll send an announcement out to users saying, that we've got these fantastic new features. Come try out, version 2. But really, those features have been running in production for weeks. They may not have been exposed to everybody, or maybe they have been exposed to it. And instead of, it more becomes about educating users and about highlighting the value that's there. We have these kind of production levers at our disposal. And we'll talk about that. So use production data. This is something that I already touched on about test data being a liability. And that we have an automated, every week after we make a release, we refresh the test database with the latest snapshot of data within production. Sometimes it happens accidentally, like it did yesterday. And then another key practice is minimizing the work in process. I know we're starting to get a little bit late, so I'm going to go through some of these things pretty quickly. One thing that we found pretty valuable, and I don't know if Chris is still here, this is something I talked with Sky, it sounds like you guys are doing it at Sophos as well. Things like single feature releases. So have the entire development team focused on building a single minimal marketable feature. So a single feature you have several people collaborating on, helps you minimize the work in process. You end up with a higher quality product at the end because you've got lots of different people that are inputting it into it. It means that what you're working on is pretty well understood within the team. Lots of value, I found. And often it means that you can tackle. One thing we set up recently, we have a storyboard. We're working on trying to pull work into our process and try and minimize the number of things that people are working on concurrently by tracking that on the board. So having no more than 2 things being worked on by any developer at any given point in time. Okay, so these are some of the practices that I talked about. I'm going to go very quickly through the tools and then we'll wrap things up. Okay, so Teamcity, automated build server that we use, it's fantastic. Ganglia, I also recommend checking out, which I touched on earlier. We use Capistrano. Capistrano is, again, from the Ruby and Rails community, but it is useful in Java space. What it allows you to do is concurrently execute commands on the same command on a set of remotes, on a set of remote servers. So what it does is it opens up several different SSH connections and executes the same command to each one, and then aggregates the results. So it's just a concurrent remote shell program, but it allows you to build up a library of commands that you typically can execute against a wide number of servers in order to do things like problem diagnosis. It's pretty useful. We're using it in kind of a non-Rails way, like we don't use it for doing deployments, but it's useful nonetheless. Nginx I talked about, it's very useful. Pingdom, Jira, Selenium. One thing we've started using lately is Puppet for helping to provision our servers, so ensure that they're set up with an identical image and that that rollout of building up new servers is a fully automated process. And so the goal there is that we can easily rebuild servers, we can easily add new servers to our existing infrastructure. Okay, that's it. That was a lot of talking, and I think there's still some questions. I know I'm a little bit over time. I don't know if anybody has to go. If you need to scoot out of here, you're welcome to. But I'm totally happy to stay and answer questions. Please.
So, are all of your customers aware that they have weekly production releases? And if so, for those who get weekly production releases, how do they feel about it? And do they do any of their own testing? Are they on these features?
So, are they aware? No, not necessarily. It depends on whether or not we are building something up for that specific customer. So this is so one thing when I talk about releasing software really frequently, one common concern that I hear is people say, well, isn't that going to be really disruptive to your users? And I think part of that is because most people's mental model for a software release is based on things like upgrading operating systems that tend to be highly impactful, highly disruptive. Really, I mean, we have a relatively small team that is working on implementing a week's worth of functionality. So the system doesn't change that regularly.
But you are adding new features.
We are adding new.
Customers need to be notified about new features, right?
We do. Yeah. So there's a few things we do for that. So one thing on the landing page, the first thing users hit when they come in, they'll see we have what we've done is we set up a WordPress blog which describes new features as they get added, and so that the RSS feed from that WordPress blog is aggregated into the landing page of the software, so people can see it. So they can see when new features are added. They can click on the link and get more information about what those features are. So that's one way to provide education, especially for things like new features. But it's also just useful. Like people can then see, how the system is changing. They understand what they can go in now and try out. What I've been actually pretty surprised by is that often, like the next morning after deployment, there will be users that will have gone in and discovered new features within the system that we may not have even written the blog text for, and it's pretty gratifying. So it does. Yeah, it shows that people are using the software in an investigative way.
What's their use changing frequently anyway? I think once that they have that expectation, but it's not a bad thing. Like they know that it happens all the time.
We're also, we are we're at a fairly early stage with the product. I mean, we've been building it up now for about 2 years. But there's a lot of co-creation that happens with our users. And so they're actively using it, and they are demanding those features. And and as a result, they will go in and discover things. And I think maybe if with a more mature product, maybe you're somewhat limited. A story that I like to tell is about eBay. So how many people have bought something on eBay? I've actually never bought anything on eBay. But eBay is one of the original internet properties, right? I mean, eBay's been around since fairly early websites on the internet. And if you look at something like the Wayback Machine, the Wayback Machine takes snapshots of websites over time, and so you can look and you can see how sites evolve. Actually, one thing that's interesting is eBay and many of these other big sites. If you look at the Wayback Machine, they're changing their site almost every day, and to no real apparent effect. But if you look back, the original version of eBay, it was standard, websites in 1997. Everything was yellow, on a yellow background. And eBay had developed this really hardcore set of users that used eBay for everything. The design community within eBay said, okay, we need to refresh the look of our site. It looks very 1997. But we know that if we go and we change the site, there's going to be an outcry from our dedicated user community. So what they did was they designed and evolved the look of their site by incrementally adjusting the background shape of the page from yellow to white. So they had this white, this new white site that they wanted, and they realized that if they did it slowly enough, that there wouldn't be this type of outcry. Now I'm sure, for them to figure that out, they probably showed they had some early prototypes. They split tested them. They showed them to different subsets of users, and they had a reaction. They said, okay, how are you going to deal with this problem? But there are definitely ways in which you can evolve the site that doesn't have an impact on users. How many people here use Gmail? I use Gmail every day, all the time. I think it's fantastic software. What version is Gmail? I mean, it just came out of beta, right? But it's been but they're changing and adding new features to the software all the time. But it's pretty transparent to me as a user. I mean, every now and again, they'll break something, but it's you can definitely evolve software in a way that is pretty non-disruptive. Yeah.
Owen, practically everything we talked about today is, let's call it tooling or process, just for the sake of word, as opposed to features. So that requires time and efforts. What is your ratio between this versus features?
I'm not sure if I entirely understand the question. Can you elaborate a little?
To create tools that allow you zero-time deployment, for example, to create, expansion and contraction tools. That's just an example. That takes time. That takes effort. When you develop this, you don't develop features. I'm not saying you don't need to, but do you know the ratio?
I don't know the ratio, but the way that I look at it is that there are a wide number of stakeholders for any given software system, right? And different stakeholders will have a different weight into that into the construction of that product. And especially in a startup company, you want to foster quite a bit of sense of ownership within the overall company. So developers are stakeholders, testers are stakeholders, graphic designers are stakeholders, end users are stakeholders, the product managers are stakeholders. So we try and balance these priorities for every weekly release. So we'll pull in a few operations related priorities, a few features, and we kind of balance it that way. And a lot of it is just based on what we feel is relative priority. The heavier weighting is definitely towards the feature development, but we try and ensure that we can make some progress on the operational issues as well. And part of that, I think, is a company mentality thing, because our objective is to build a system that will scale to a very large number of users, a very large number of buildings. Our goal is to be able to get to 1 million buildings within 2 years.
And that's exactly why I'm asking, because when you grow, the moment you have one person who is doing accounting right now, when you grow, the moment you hire CFO, he will start asking these questions.
Well, I can only speak about our context as it is right now. And right now, that's how it works.
Thank you.
How do you manage performance? How do you optimize that?
Performance?
Application performance.
So
there are so many changes in one. How do you manage that?
a lot of it is from Ganglia. So looking at the charts in Ganglia, you can see how performance is trending over time. We have conducted some performance tests where we've pulled servers out of the pool within production and see how that affects the load on the other servers. So there's a book by I think it's by John Alsbaugh. Anyway, it's one of the guys at Yahoo that's about capacity planning, and their thesis for running large sites like Yahoo and Flickr is to say, we don't even bother with performance testing features because outside of the production environment, because we can't reasonably simulate the sort of load and the variety of interaction that you would see within a high traffic, high scalable site. So they do all their performance testing within production, and they do it just as how I said. Like they gradually pull servers out of the pool, they look at how the load ramps up, and until it hits some sort of threshold. They can extrapolate. They do some number of manipulation, but it's all done within production. It's not done within test.
So you are doing this on production.
Yeah, that's right. Like part of this approach, I'm finding also is that it's like where I see it, especially in startup companies, with the line between like production can be used for a lot more things than it's currently used for, and part of that is because there is this chasm within most IT organizations between development and operations. That operations, supports the system, developers build the system, but the implications are developers and not understand the environment that the software they're building is actually running on, and the operations staff don't really understand the software that they're supporting. And that is a very dangerous gap, and I've seen that in way too many organizations. And it looks great on an org chart, and I'm sure that there are some regulatory reasons that require that type of separation, but more often than not, it is unnecessarily divisive, like where you've got operations groups in different departments and different buildings from developers. And that lack of communication, to me, is like, it's hugely detrimental to the construction of a successful software system.
So some of the performance testing you're talking about, you mentioned dark launchers. You can put it in, turn it off, and let it get the data and do whatever, and then you go, yeah, it seems to be okay.
Yeah.
And then you turn it off.
That's a great example. Like one story that I heard recently, this was with Facebook. So Facebook decided that they had this partnership with CNN, and they wanted to be able to show a live streaming feed from CNN within your Facebook page, and then have a chat alongside where people, like your friends, could discuss what it is that you're seeing, and like many different people can engage in this discussion, and then get feedback, and et cetera, et cetera. But they realized that, of course, it was going to be extremely resource intensive, and they weren't too sure whether or not they could sustain it. And they did this. They decided that they were going to do this for the November American election last year. Right? So, at a point in time when they knew that traffic would absolutely spike, but of course, like from a publicity perspective, it was a fantastic way to drive new users towards Facebook. So they took this into account when they designed it, and everything that they had within that version of the site was disableable. Like they could selectively, they could reduce the number of images that were shown, like down to that level. Everything from turning off the chat, reducing the frequency with which chats could appear. So there's a ton of stuff you can do. And what I found is it's often extremely low cost in order to be able to build these sort of switches into systems, especially once you have a little bit of infrastructure in place that, like a place that you can go in order to be able to turn things on and off. I wouldn't necessarily recommend it, but like I've talked to some companies that use they do everything through JMX, like all the control of switches within their system is done through JMX to the level like they've got a JMX console for somebody within marketing. So they selectively control things. Like it's that to me is not necessarily a good approach, but there are many different ways in which you can expose this sort of functionality within the system. Yeah.
Do you have any experience of running this sprint mechanism when you're doing a continuous deployment on multiple projects at the same time, with different hosting environments?
So when I talked about our team structure, I glossed over it a little bit. The developers are actually really split into two teams right now. One that's working on kind of the key data rendering, client-facing application, and the other that is working on like this integration connectivity aspect, pulls data in from different systems. These are decoupled systems that can be deployed independently, and so we have independent release schedules for them. So that's just two teams that are running in parallel. But so far, it works fine. And there's value associated with having that, like having the ability to decouple the releases. But at this point in time, like accountability for, like it's not like it's all being funneled into a common operations group. Accountability for the deployment is the individual team. How many teams or projects are you thinking about?
Well, I work for services companies, so we basically have like 20 projects on at the same time.
Yeah.
And they're all
single website is often like consists of several different subsystems, and those subsystems may be independently releasable. I don't know. I don't know if that answers your question, but at least within this specific context, we're sufficiently small that it's not really an issue.
One question.
Yeah.
I was wondering what Pulse Energy's differentiator is from the stuff that Google's doing with their smart metering software.
So at this point in time, Google is primarily targeting the residential market, whereas for us, our on institutional and industrial buildings. So it is like kind of it is a different target market, even though there's overlap with what it's going after. And also Google's model is different. Like Google is working through the utilities. So the utilities, they'll have a partnership with the utilities. Utilities will send data to Google, and then Google will provide that information for users. Whereas our model is dealing directly with clients and helping them manage the energy in their buildings better. So it's a pretty different model, but it's interesting. Like this, it's an interesting market to be in because it's really heating up, and there are a lot of large competitors that are doing things that are somewhat similar. And of course, you know, if Google does it, then Microsoft has to do it. So Microsoft has also got their own version of energy monitoring for the residential market. Anything else? Thanks a lot for coming. Oh, okay. So there's a few announcements that I should make before we wrap up.